Well, hello, students. So here we are on the second section, going nice and slow in this online-only environment. The beginning of this section starts off with this skills you need. You can go ahead and give that a shot. They're giving away a little bit of the chapter by having you evaluate this particular expression. We'll see why here in a minute. And they are asking that you graph a couple functions, right? Make sure that you can graph the parent function of x squared, or parent quadratic function, that you can graph this function as well. You know, it is going to point down with the axis on the y-axis, the axis of symmetry, and the vertex will be coming off 0, 2, because this is the y-intercept, and our vertex is always on the y-axis if we don't have a b. And then finally here, this should be wider than the parent function because we have an a value. It should be pointing up, and our vertex at -1 on the y-axis. All right, so if you graph that, awesome, it should look like that. We're going to go ahead and start here where we say, okay, if we only had an a and a c value, like we did in the last section, we know that our axis of symmetry is always going to be the y-axis, and our vertex is always going to be on the y-axis as well, because our vertex is always on the axis of symmetry. So they aren't very exciting, all right? However, let's go ahead and we're going to set the y-intercepts to 0. Notice there's no c value here, and in all three graphs you'll see a y-intercept of 0. And let's go ahead and give an a value of 2, and then let's just adjust the b value here and see what happens. So we're going to increase the b value from 2 to 4 to 6, and as we do that, we watch the vertex go down and to the left, down and to the left, down and to the left. And if you were doing an experiment, oh, I was going to try something. Captions. So if you were going to try an experiment and build a table and try to figure out the relationship, we would see that somehow changing this b value not only moves our vertex to the left, but it also moves it down at the same time. We're only changing one value here, but somehow two values of our vertex are changing. And we're going to see why that's the case here in a minute. But what we're going to see is that there's a relationship between the b value and the a value and the vertex and line of symmetry of our graph. This b value is actually pretty important, all right? So if we looked at a ratio of our, oops, let's see, are you going to let me go down there without popping up the menu? I don't think it is. Nope. Nope, the menu's going to pop up. All right, so I'm learning here, folks. So if we look at the b value and, and the a value, in that first equation, a ratio of those two values is 1, the ratio of the two values on the second graph is 2, and the ratio of the two values on the third graph is 3. And I don't really see that relationship here. Oh, wait a minute. Okay. If I look at the x value of my vertex, or the line of symmetry for my first graph, that's 1/2. And related to the ratio, that's half the ratio of b to a. And if I look at my x value here on the second graph, that's 1, which is 1/2 of 2, and 1.5, which is half of 3. So there's got to be a relationship of a half in there, right? At least you would think. Half of the ratio of b and a. But then we also seem to be moving in a negative direction, even though we are making this number positive. That seems a little weird. But it looks like if we just took this ratio of b over a and multiplied it by -1/2, we would get the x value of our vertex, which is also the equation for our line of symmetry, our vertical line, x equals whatever that value is. So that appears to be the relationship. So let's go ahead and verify that out. If we go ahead and work this out, we will see that it is -1/2 times b over a, or the ratio of b to a. Now, a nice way to simplify this is that we just go ahead and slide that negative up to the b. We have a negative b over the product of 2a. So here we develop a property. And that property for a quadratic function is defining the x-axis of the x-coordinate of the vertex, which then tells us the axis of symmetry. So for the graph of y equals ax squared plus bx plus c, where a is not 0, the line x equaling -b over 2 times a is its axis of symmetry. Oh, looks like I came unplugged somewhere. Sorry about that. Okay, there's that. And then bam, we we are back in business. So we just need to start using negative b over the product of 2 and a, and that will give us our axis of symmetry. So we're going to go ahead and try that out. So here we are given this function to graph, y equals negative 3x squared plus 6x plus 5. The negative 3 tells us that we are going to be pointing down and we are going to be narrow. The 5 tells us that our y-intercept is going to be 5. Other than that, we need to use the b value to find the axis of symmetry as well as the vertex of our function. So first thing we need to do is say, hey, wait a minute, how do I find the axis again? Oh, it's that negative b over the product of 2a. So x equals negative b over 2a. We start substituting. It's negative b, and our b value is 6. Therefore, we have negative 6 over 2 times a. In this case, a is negative 3, so we have to substitute into parentheses. Let's not forget our signs. The negatives cancel out. 2 times 3 is 6. 6 divided by 6 is 1. Therefore, the axis of symmetry is the vertical line x equals 1. We now go ahead and substitute 1 in the equation to figure out where the function crosses the vertical line of x equals 1, and that tells us where our vertex is, because our vertex is always on the axis of symmetry. In this case, our axis of symmetry being 1 is quite nice. We just substitute 1 into parentheses. Negative 1 squared times negative 3 is negative 3, plus 6, that gives us 3, plus 5 gives us 8. Therefore, our vertex is x is 1, y is 8 for the coordinate pair 1, 8. Step 2, we need to find other points on the graph. So we already know that the y-intercept is 5, so we're going to graph that. And then we just start substituting x's that are going to be easy to calculate. Now, we know our axis of symmetry is at 1, and we already have 0, so we can graph the mirrored point across the axis of symmetry of our y-intercept, which is 1 unit away from the axis. So therefore, this point exists 1 unit away from the axis on the other side. And we can go ahead and start substituting other values. Now, great values to substitute are 1 and negative 1, because they're really easy, especially when you square them, and fast, and they don't get big very quickly. If you wanted to test out 5, 5 squared is going to give you a very large value, and then multiply that times, well, not very large, 25, but times negative 3 is going to give you negative 75, and unless you're planning to graph numbers that big, you likely do not have a graph that is going to allow you to plot that point. So just be mindful. You're trying to keep close to the axis of symmetry when you choose your x values. So don't forget, anything that you try out, you can always graph its reflected point over the axis of symmetry. Now you know this is narrow because of the negative 3a value. Therefore, it's going to be very steep, which means the numbers are going to get very large or very small, depending on the direction that it's pointing, very quickly. So this is why, even trying a value like 4, it's going to get you off your graph pretty fast. Okay, so now it's your turn. You are going to graph this function. Go ahead and give it a shot. I am going to do it right now, so if you want to do it on your own and then watch the video, now is the time to hit pause. Okay, so first thing you need to do is say, hey, what is my equation? Oh, actually, verify your values, right? My a value is 1. My b value is negative 6, right? That's a minus sign there, so we've got a negative 6b value. Your axis is x equals negative b over 2 times a. Go ahead and substitute in. Substituting into parentheses, folks. Please do not forget to do that. Your sign will be wrong if you forget, most likely. So negative times negative is a positive. 6 divided by 2 is going to give you 3. We're going to go ahead and substitute that back into our equation to figure out what our y value is when x is 3. That will give us our vertex. We substitute in 3 here, and we find out, there we go, that y is 0 when x equals 3. Alrighty, so then we start graphing this. So we know our axis of symmetry is at x equals 3, so we have that vertical line, that's our axis of symmetry. We know our vertex is at x is 3, y is 0. Awesome, now we just need to start picking points. I would pick 2, and then graph its mirror, then I would pick 1 and graph its mirror. I'd probably pick 1 first. And then of course we're going to graph the y-intercept, which is 9. So we've got a y-intercept of 9, that's going to end up right there. And then a couple points in, we graph the mirrored points on this side, and you're good to go. So we end up with this function, with this graph, excuse me. So we've got that y-intercept of 9. When I substitute in a positive 1, 1 squared is 1, minus 6 times 1, which is minus 6, so that gives us negative 5, plus 9 is a 4. Therefore, when x is 1, y is 4, then I graph its mirrored point. Do the same thing with 2. 2 squared is 4, minus 12, that gives me, what is that, negative 8. and then negative 8 plus 9 is 1. Therefore, when x equals 2, y is 1. I graph the mirrored point, and we are golden. By the way, I got this graph by going to desmos.com and graphing from there and taking a screenshot. Just a recommendation if you want to do that. So here's something to consider before we do the next problem. From the previous section, you saw that an object dropped, not from space, from above ground level. Its height can be described by the function negative 16 times t squared, where t is in seconds, plus c, where c is the initial height of that object in feet. So at time t. So the thing is remember we said that negative times, at least I did in the previous video, negative times don't make sense because we're dropping an object basically from the vertex of the graph and watching it accelerate till it hits the ground, right? Follows along that parabola. Well, things don't always have to be that way, right? We could actually shoot the object up into the air, and the equation that describes that height, or the height of that object, is negative 16t squared plus vt, where v, or the b value in our quadratic equation, represents the velocity, or the initial velocity of the object as it is shot up into the air. And then we end up with the plus c. Now that plus c is going to have a different meaning here. Well, we'll get into that in a second. But just notice that we've got a b value now, and that is the velocity of the object as it is shot above or into the air. Into the air, not above. Okay, off to the problem. Here we go. Okay, fireworks. Ooh, that's fun. Shoot those up in the air, watch them go. I think that's a song, Celine Dion or something. Anyway, suppose a particular star or firework projectile is projected from an aerial firework at a starting height of 520 feet with the initial upward velocity of 72 feet per second. We got to keep it in feet and second for this equation to work. Feet for distance and seconds for time. How long will it take for the star to reach its maximum height? So here we have that c value, okay, because, and only because, we are launching this aerial firework from some sort of tower structure that's 520 feet in the air, maybe the top of a building or something like that. So again, it's our y-intercept. It's our y-intercept again, but most often when we're shooting something off of the ground, that y-intercept is 0, so we won't see it. However, if there is a c value, that means we are launching something from a height above the ground. All right, let's get to the problem. We have our variables, we have our equation, we're good to go. So we need to find the coordinate of the vertex. We have a b, we have an a. Now in this case, our a is negative. So we're going to have a negative in the denominator and a negative in the numerator, and it's going to cancel out, at least the sign is. And we're going to have a positive x value for our axis of symmetry. So step 2, we take that x value, plug it back into our equation, calculate what the y value is, or in this case, the h value, or the height, at that given time, right? Time 2.25 seconds, so 2¼ seconds, this thing is going to reach its maximum height, and that maximum height is going to be 601 feet off of the ground, all right? And if we were to graph that, and you're visually graphing that in your head, I guess that's not visually, mentally graphing that, that's the vertex of our parabola. And our parabola is facing down, which you know because our a value is negative. Okay, your turn. And this one I'm not going to do for you. I want you to give this a shot, just 100% on your own. I'll check it when you submit it. A ball is thrown into the air with an initial upward velocity of 48 feet per second. Its height in feet after t seconds is given by the function h equals negative 16t squared plus 48t plus 4. What in the world does that 4 represent? Oh, I'm pausing so you can think about it. A ball is thrown into the air. It's not launched into the air, it's not exploded into the air, it's thrown into the air. So most likely, someone has the ball in their hand, and they're launching it into the air from a height of 4 feet off the ground. So this person might be 5 feet tall. They're launching it from a foot underneath the level of their head. Therefore, the ball is getting let go and sent into the air at a 4 feet initial height. How many seconds will it take for the ball to reach its maximum height? That's for you to figure out. And what is the ball's maximum height? Good luck. Give it a shot. Okay, so then now this is going to hopefully rekindle not rekindle, that's not the right word, revive? I don't know. You're going to have some memories of graphing inequalities. Remember shading either above or below the line? Well, guess what? Quadratics, you can shade above or below the curve if you have a quadratic inequality. Same rules apply for the greater than or equal to symbol. If it is greater than or less than and equal to, then the line is solid. If it is just greater than or just less than, then the line is dashed. Other than that, if y is greater than the quadratic function, then you shade above. If y is less than the quadratic function, then you shade below. Go ahead and graph these guys. It's going to be best if you have graph paper. You're going to need your skills in finding the axis of symmetry from example 1 and 2 to get this done. Good luck. I don't have this for you. You can always test this out, guys, by going to desmos.com and plugging in this equation to verify that you graphed it correctly. This is why I'm not doing it for you. I want you to know how to self-check these. Go to Desmos. Just do it. Okay, so practice. What do I want you to do to practice? I want you to do all of them. All of them. There's only 22 problems, and you're going to need practice graphing these, and the 5 through 10 is just matching. You're going to have to do a little bit of work. Some of y'all might be able to do it mentally. Even if you do, get some scratch paper and write out, if you can see, negative b over 2 times a, so that's negative 6 over negative 2, and you know the axis of symmetry is going to be 3 for d here. Cool, awesome. Write it down anyway, okay? Just use this time to practice finding the axis of symmetry, and just write it down, all right? So then, doing 1 through 10, and then 11 through 22. Now, remember when we started this chapter and I said make sure to get some graph paper? Well, if you did it, go ahead and give your past self a high five, because proper planning puts you in a good spot to have some graph paper. If you don't have a lot of graph paper because you just kind of blew it off, or didn't make the time to get out and get it, then shake a finger at your past self, and that's okay. Just sketch out a graph, all right? If you want to do this all digitally, I will totally take screenshots off of Desmos. Yeah, that'd be great if you want to go that route, all right? Either way, just give it a shot. Again, hope you're happy, healthy, and not too bored on this break, and if all goes well, we'll be seeing each other sometime before the end of the year. All right, again, I don't know how to end videos. Have a good night.